Welcome to Back to the Drawing Board with Scott Lucas and Holy Cow. Mr. Ho Sr. was a big fan of Harry Carey and the Chicago Cubs. Anyway, today's video is electric shop furnace wiring and testing. Here's what it looks like. This is a real pain in the butt trying to get this coil down in those bricks. The first attempt failed in several ways. The 108 inches isn't 108 inches. Now, the face of the brick is 4.5 inches times 8 makes 36, and it's going to go around there 3 times, so that's 108. However, the real measurement is 4 3/4 because of the notch in it. So 4 3/4 times 8 is 38. Times 3 is 114 inches, so I gotta stretch this thing some more. That's getting worrisome now. Well, I'm gonna stretch it again and see, and then we'll find out if it goes in there. I think I'm gonna heat it up by itself. Well, we'll see what happens. We'll see what happens. Okay, well, the first coil was too short at 108 inches, so I went ahead and I stretched it to 116 inches. And it was still too short. At 108 inches, the spacing was 0.139 between the windings. Now this one I just stretched at 120 inches, and the spacing comes out to be 0.150. So I don't know if these things are going to get too light and just burn up on me or what. But hopefully at 120 inches now, I give up on the math. I don't even know how to do. Well, I figure it. I'm just guessing at this point. Hopefully 120 inches will make it 3 wraps around this thing. If it does, then the third element will be easy. So we're gonna find out here in a bit. The thermocouple that I ordered from off Amazon, you can trim it to length, and it comes marked. One of the electrodes or one of the wires is marked with red dye. You would think that would be positive, but no, that's negative. The marked one with the red is negative. So, keep that in mind. Now, here's the trimmings of it. I cut off because this is the one that fits in my furnace. And I just decided, well, what the heck? Let me see if I can't put those back together and make another one. I have to test it yet, but give it a twist and a little heat with a little bit of welding rod on the end, steel rod, and I think it's going to work out fine. I just, make up an insulator and a terminal block. Not a big deal. Just remember, if you're ever doing this, that with this thermocouple from Amazon, the red marked wire is negative, not positive. This is the second element that I'm heating up right now. It looks like 6.68 amps at 239, 240 volts. Yesterday when I did the first one, it was at I don't remember how many amps, 6.79 amps, but I was getting 248 volts in here. So I guess the temperature has something to do with the delivery system here. I'm not sure. I like 240 better. I can deal with that. But in any event, the reason I'm heating that coil up is to try to get it to anneal it, just so I can get it to stick down in those bricks. That cut system that I made didn't work out quite like I wanted. So let's take a look down inside and see what happens. So see, it's kind of, well, yeah, it's a little wobbly. I've stuffed all kinds of stuff in there to try to get them to hold. Here's a quick tip. And I don't know where, I got it off the YouTube somewhere, but I can't find where I found it. But a pair of snap ring pliers, when you're installing these coils in a groove in a brick, like I've been doing, these you can stretch them using these, and then you can always pinch it. You can pinch it back too, So like if it's bulging out and you need to pinch them down, you just go through and pinch them down. And so you can adjust, you can fine tune it with snap ring pliers and a pair of needle nose pliers. Alright, this is element 3. Now it's a couple hours later in the day, and the line in is now at 246 volts. So we're pulling right at 7 amps at 246 volts, 245, 46 volts. By 2 o'clock, by noon, 2 o'clock this afternoon, that'll be up to 250 volts. Sure changes the watt ratings, or changes your calculations if your line in is that fluctuating. 6 volts is a lot. 245 at 7, that's going to be, I don't know, 1700, 1800 watts. I'll have to figure it out here in a minute. The second element calculated out at 1600 watts. The first one, late in the afternoon, was like right at 1800 watts. We're just going to have to tie them all together and find out what goes on. But in any event, it's going to go over 4500 watts. It's all wired, and it all pretty much fits. So there we go. Well, I gotta put my cord cap on the end yet, but other than that, wire the shed now. Alright, well, we'll see what happens tomorrow or the next day. Well, this is unexpected. I just wired the shed for this thing, put the cord cap on the cord. Turns out the cord was long enough to reach out to the receptacle. I wasn't going to fire this thing up inside, but I just couldn't not do it. So here's the second time I've turned this thing on. I don't have the directions in front of me to program the PID, so it's running, I don't know what it's doing, but it's heating up, and it's at 100% power. I don't know what 8.2 and 8.1 is right yet, but they're starting to glow. I'm not going to run it too long. I want to go through a series of drying out. Run this thing up to 200 degrees. Have you ever noticed when somebody's proud of something, it's hard to get them to shut up? All wiring, never a spark or a pop or a short or anything. I nailed the wiring. It's pretty exciting. This has been months of work. So now I get the programmable, I get the paperwork on how to program it, and we'll see what's going to happen.
It's complete.
Blah, 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 blah.
Yeah. Okay.
Now I just got to figure out the PID. There's that one video online I've been watching, and I've got the paperwork up at the house. I just don't have it down here. A big thank you goes out to George Duncan at barleyandhopsbrewing.com, along with his YouTube channel. George has put together a series of great videos concerning this MyPin PID. Straightforward and to the point. Nice work. Thanks, George. In the taping of this testing, I have video of every 100 degrees of temperature rise, just in case something happened that was spectacular or even tragic. Well, no fire or explosion, so, in the interest of time and attention, I put this together, down and dirty in less than 30, with a graph at the end. Alright, well, I just couldn't resist. Found this voltage current meter on Amazon for 18 bucks or something. This thing is going to provide me with so much information, it's just out of this world. Right now, I got outside voltage at 251, and it's using 1.5 watts of power. So, and I've had it on, so the energy thing is a little bit wacky. And it's programmable. I don't know. I'm not even going to worry about that, but watch this. Okay, so our PID goes through its test. I've got it set to a top of 1400 degrees. Inside the furnace right now it's 85 degrees, so I just had it on for a little bit. Okay, watch these numbers, because I'm going to turn the coils or the coil elements on now. Okay, there, 4,950 watts, 20 and a half amps. I think that information right there is priceless. It turned out to be more digitally controlled and computerized or whatever than I thought. It sure does look cool. Thanks for watching. Next time we're going to melt some aluminium or aluminum or something. Depends on how you look at it.